Way 60 deals with being able to graph correctly a set of data points. For like the living environment regions, the chemistry expects you to be able to graph correctly, and that means that your scale has to be equally spaced or have an equal interview and equal interval, and points have to be plotted correctly, meaning that if the instructions tell you to put a dot with a circle around it and connect them, you must do that in order for full credit. The chemistry regents is notoriously strict when it comes to your graph. Let's try some problems. The atomic number and corresponding atomic radius of the period 3 elements are shown in the data table below. So here I'm shown atomic number and the corresponding atomic radius in picometers. On the grid below, mark an appropriate scale on the axis labeled atomic radius in picometers. So it expects you to use this data and come up with an appropriately spaced interval that will accommodate all these numbers up to 160. Please note that for these questions, you need to consult the maximum number given in the data in order to figure out what your appropriate scale is. You notice that there are 20 lines here, so think about what should you count by in order to accommodate up to 160 picometers for the y-axis. Since there are 20 intervals, it makes sense to count by tens. So if you count by tens, it will easily accommodate up to 160 because there are 20 intervals, so that the 20th line will correspond to 200. And all you have to do is plot them correctly. It says atomic number 11 corresponds to atomic radius 160, so plot that point. The next point is 12, 140, and then 13, 124. So 124 should fall between 120 and 30, and then you just plot the rest of the points. Typically, it'll ask you to put a circle around the dot and then to connect them in order to show the trend. For this trend, you should remember that the atomic radius decreases across a period, across period 3, primarily due to the increasing nuclear charge. And you recall that the nuclear charge corresponds to the atomic number. So those positive protons are squeezing the electron shells closer toward the nucleus, which is why that radius decreases. But that's a side note. Let's go on to the next question. At room temperature, a reaction occurs when potassium, I believe that's potassium iodate, is mixed with sodium bisulfite that contains a small amount of starch. The colorless reaction mixture turns dark blue after a period of time that depends on the concentration of the reactants. In a laboratory, 12 drops of 0.02 molar sodium bisulfite aqueous solution containing starch were placed in each of 6 test tubes. A different number of drops of 0.02 molar potassium iodate and enough water to maintain a constant volume were added to each test tube, and the time for the dark blue color to appear was measured. The data was recorded in the table below. So here we're adding in potassium iodate, drops at a time, and we're calculating how much time it takes for the dark blue color to appear in seconds. It says on the grid below, mark an appropriate scale on the axis labeled time in seconds, and then for part B, plot the data from the data table. Circle and connect the points. So fortunately, it provides you with the number of drops on the x-axis. All you have to do is come up with an appropriate time. So think about the number of lines present and what should you count by in order to accommodate the time for dark blue color to appear. Now please note, you have to consider that whatever scale you use, it has to accommodate up to 210 seconds. Since there are 12 lines, it makes sense to count by 20s because doing so will take you to a maximum of 240, and that will be able to accommodate this large value of 210. And at that point, it's just a matter of plotting the points. At 2, you have 210, which is halfway between 200 and 220. For time 4, to have 4 drops, you have about 88, which is roughly between 80 and 100, but slightly closer to 80. At drops 6, you have 49, which is roughly halfway. And then you just plot the rest of the points, circle them and connect them. And you'll see that the time is decreasing the more drops that you add. Next question. In one trial of an investigation, 50 milliliters of HCl aqueous of an unknown concentration is titrated with 0.10 molar sodium hydroxide aqueous. During the titration, the total volume of sodium hydroxide added and the corresponding pH value of the reaction mixture are measured and recorded in the table below. So this tells you how much sodium hydroxide you're adding, milliliters at a time, and the corresponding pH value of the reaction mixture. On the grid below, plot the data from the table, circle and connect the data points. So for this table, it tells it on the x-axis, it tells you the total volume of NaOH added, and it even gives you the scale for the y-axis. So at this point, all you really have to do is plot the points. But please note that sometimes neither the data points for the x-axis or a scale is given for the y-axis. So sometimes you will have to do this information on your own. So you should be able to comfortably do it, come up with an appropriate scale that accommodates the data points given in your chart. You'll see that at a volume of 10 milliliters, that corresponds to a pH of 1.6. So the first data point will be at 1.6. Then at 20, it corresponds to 2.2. At 24, and notice that this is counting by 2, so 22, 24, it's 2.9, which is closer to 3. And then when you plot all the points, you'll see that as the volume of NaOH is increasing, the pH, or the level of acidity, is decreasing. So when it comes to graphing, just be sure that your scale that you provide will be able to accommodate all the data points given in your chart. Please note that sometimes the chart's not even provided. It'll just simply ask you something maybe from table S, like plot densities, plot melting points, plot atomic radius. Any one of these values is fair game, and it will ask you to come up with an appropriate scale. Maybe it might ask you to circle the points and connect them. Whatever you do, just be sure that your scale is evenly distributed and all the points are plotted correctly. Thank you for watching.